your seat. Make sure that your camera is on your face. We should all take out the review packet from yesterday. I know that I sent you a science. You all had a science packet, and there was something specific for today. What we're actually going to do is we're just going to continue to work through the review packet, which has this cover on it. So we're just going to continue to work through problems from this review packet. So we finished off yesterday. I gave everyone a homework assignment, which was to finish that one problem which we were working on.
Jalen, prop your phone correctly, please. You're not the only one using their phone, okay?
And so I'll go ahead and let's look along. We were working on this problem here, number 13A. Does that need to get focused a little bit better? Okay, 13A. We finished 13A and we're doing 13B. So the answer, which you should have already completed, actually, everyone lift up your packets. Let me see your packets because that was also part of your homework. So let's see those printed packets. If you are not able to print, just send me a message and tell me that I'm not able to print things right now. But you should be great. You should be working along on a piece of paper or in a notebook if you do not have the printed packet. So the answer to B would, the final step is that energy, we're using the relationship energy is equal to power times time. We already solved for the energy in the previous problem. It's 2,640 watts. And we have to multiply it by time, and the time is 1 hour. So this is actually pretty straightforward. We just do 2,640 watts times 1 hour, and then that's 2,640 watt hours. The units are called watt hours. If we want to turn that into kilowatt hours, which we often will do, remember that K, like kilo, means 1,000. So 2.640 kilowatt hours means that it's 2,640 watt hours. Okay. So, yep, if you don't have it printed with you, just you can follow along on your screen. You should have a piece of paper or a notebook. Any questions on the way that we solved part B? Okay, let's turn to part C. I'm going to switch over to the actual to a blank page here. All right, are you all, give me a thumbs up if you see the review blank on the screen. Okay. So let me jot in here, our solution for this one was 2,640 watt hours. The next question is asking, your electric company is going to charge you 10 cents per kilowatt hour. How much does this space heater cost you cost you for the hour that you use it? Daniel, you're frozen. Okay, we've spoken to you about this several times in several different classes throughout the day. Let's go to Chanel. Chanel, what do you think? What might our plan be here?
Our plan might be to multiply the power times the time.
Yeah, so actually, yeah, we're gonna multiply the energy, right? Because kilowatt, very close, Chanel. But yeah, we're gonna multiply the energy times the time. So we have 2,640 watt hours, and we're multiplying that by 10 cents. This is supposed to be a dollar sign here. We're multiplying that by 10 cents per watt hour. And so how much is this going to cost us, Jessica?
I need to get my calculator.
No, you don't, Jessica. Come on. You're multiplying by 0.1. You're multiplying by 0.1. That's the same thing as dividing by what number?
10.
10. So you're dividing 2,640 by 10.
26.4. I mean, no. 264.
It is 264. But you know what? I just noticed that even I made a little bit of a mistake. But that's fine because I'm constantly checking to make sure that things make sense. And that's what we should all be doing. I just looked back into the problem and I noticed that this is 10 cents per kilowatt hour, not per watt hour. So we have to make a little bit of a change here. Instead of using 2,640 watt hours, what do we need to plug in instead for our energy? Let's go with Carlo. What are we using for our energy? Try that again. Carlo, unmute yourself. For some reason, I'm not able to unmute you, if you can do it.
Jalen, Kayla, I'm not sure what's going on, but we need to see your face. Everything okay, Kaylin?
Yeah, oh, sorry, the video wasn't on.
All right, let's go. Carlo, we're going to come back. We're going to circle back around and try to figure out that audio problem with you. Daniel, you're still not visible in class. If we can't see your video for a good portion of the class, you won't get attendance because we're going to assume that you're not here.
We're
We're gonna
contacting
send
your
you away
parents
from
as
your
well.
computer.
It's just becoming a problem every day.
All right, so let's go to Morris. Morris. Oh, go ahead.
So I think now since we know it's like since it's kilowatt hours, we have to put 264 instead.
Close.
Because
Remember that a kilowatt hour is equal to 1,000 watt hours.
2.64.
There we go, 2.64 kilowatt hours. So now we multiply 2.64 kilowatt hours times 0.10 dollars per kilowatt hour. And we're circling back to Jessica because we were working on this one, Jessica, together. So Jessica, go ahead, divide 2.64 by 10.
0.264.
Yep, 0.264. And that's just going to be dollars. So it's going to cost you pretty much 26 cents. I'm going to model. Let's go on to D. This is a circuit problem. So reminder, let's see, some of these formulas are up here. I'm just going to rewrite them on the side for us that I need to follow along. So we have Ohm's law. Hey, why is that going away? Okay, I'll write it here. Ohm's law is that V is equal to IR. So we have a circuit and the total resistance is 8 ohms and the current is 1.2 amps. It asks me what the voltage is. So we can identify here that we're given R, the resistance, is equal to 8 ohms. We're also given that the current, I, is equal to 1.2 amps. We're being asked for what the voltage is. So what is V? The relationship that we're going to use, this is Ohm's law. This is what we call Ohm's law. voltage is equal to current times resistance. So I'm looking for voltage, I have current, and I have resistance. So I have everything I need to just do a little bit of algebra, a little bit of arithmetic. So V is equal to, I'm going to plug in my current, 1.2 amps times 8 ohms.
So put the comb away, come forward, get back on task, please. Put the comb away, completely away. Move your chair all the way in.
And go ahead and check my math on this. I think that might be 10. I think that might be 10 volts. Let's check this. 1.2 times 8. Oh no, that's 9.6. Are we getting 9.6? Give me a thumbs up if 9.6 is correct. 1.2 times 8. So now what I want each of you to do is I want you to take the next 2 minutes, and I want you to do question E on your own, and then we're gonna go over the solution together. So you're still using Ohm's law. Use Ohm's law.
Mister,
Yes.
what is Ohm's law? I kind of forgot.
Ohm's law. So Ohm's law is that V is equal to IR. I wrote it up here. I wrote Ohm's law right here. That's what it is. The voltage is equal to the current times the resistance.
Okay, thank you.
You're welcome. Carlo, come back on video. Jalen, fix your camera. Okay, Jason. So walk me through, everyone, we're still working. Jason, walk us through, what are we given so far? I'm gonna start to fill it in.
Okay, we're talking about letter E.
Yep.
Okay, so we are given, so they give us that we have a 12V battery, and it is saying that we should power up a light bulb with 60 ohm.
Oh, that's a
resistance.
6. That says 6 ohms.
Carlo,
Oh,
come back on
6.
camera and stay there, okay?
With 6 ohms resistance.
Okay, so we know that voltage is equal to 12, and we know that resistance is equal to 6 ohms. 12 volts, 6 ohms. Vicky, what are we looking for in this problem?
In this problem, we are looking for the current through the light bulb.
Yep, we're looking for the current, and we use the symbol I for current. Vicky, what is Ohm's law? We used it in the last problem. So what relationship can we use? The formula.
V equals IR.
V equals IR. There we go. Okay, Leilani, do we have everything that we need to be able to solve this problem?
Yeah, we can just plug it in.
Just plug it in. So we have V is equal to IR.
Wait.
12 volts is equal to I times 6 ohms. I'm trying to unmute Daniel, but I'm also, there we go. Daniel, you're unmuted. So how do we finish off this problem?
To finish that problem, what we would have to do is divide the 6 on both sides. So then we can find the current.
12 volts divided by 6 ohms is equal to I,
Yep. Yes, sir.
which is equal to 2 amps. Any questions on solving this problem? Take another 20 seconds to jot down any notes on the problem solving. I'm gonna model the next problem, and then we're gonna do it like we just did this one. Okay, so I'm gonna move on to problem 14. So we've got diagrams of circuits here, and what it wants us to do is just draw a diagram using circuit symbols. So to remind us what those symbols are, I'm gonna write them over here. This is a battery. This is a need more space. A symbol like this is a battery. A light bulb would look like this. That's a light bulb. Just a straight line is a wire. And this would be a closed switch. And this would be an open switch. Open. So I'll model the first one, and then you guys draw the other two. So I see here that we have a battery. So I'm going to go ahead and I'm going to draw a battery with the long line and then the short line. I see a wire that comes out of it. So I'm going to draw a wire that comes out of it, and it connects to a light bulb. So I'm going to draw a light bulb symbol. The wire comes out of the light bulb and it goes to a switch. It actually says the switch is open. So I'm going to draw an open switch. The wire then goes back into the battery. For number 2, this one right here, just a note, it might be hard for you to see on your screen or your paper. The light bulb is on. So that's important information. This light bulb is being powered. Bulb is powered. So take the next minute to
Really quick, so now go.
take the next minute to fill out the next 2 diagrams. The bottom one's a little bit tricky, but it's definitely doable. Just take your time and go slowly and draw in each feature as you go using the key that I wrote here. Yes, Daniel.
Sean, turn your light on, please. Working in the dark is actually not that good for you.
Okay, so I've gone ahead and I've filled in the second diagram. What we want to do is do a quick check. So can you take your review papers or packets or whatever notebook or pad you're using and hold it up to the camera for me? Let's do that now. So let's put our pencils down and we're going to a little bit higher, Jason. Thank you. Okay, cool. Bailey. All right. Carlo, can you hear me? Give me a thumbs up if you hear me. Okay, show me your paper or show me what are you working on? All right. Let's go on now for the sake of time. Let's do these multiple choice questions. Let me get this out of the way here. Okay. So multiple choice questions 15 and then 16 A, B, C, and D. I know that this was one of those things that we had questions about. So I'm going to give you a reminder about parallel and series circuits. A series circuit, actually, let me ask you guys, because I know that there are those of you out there who can tell us, how can we tell what a series circuit is? Tanzel's got a hand up. Let's go to Tanzel. Go ahead. How can we know if a circuit is series?
A series circuit is basically like it's just one circuit, right? So it's like basically like a regular rectangle, right? It's like wires in like a rectangle or circle, whatever shape, right? But it's not yeah. So it has like yeah.
So a series circuit only has one path for electrons. What about a parallel circuit? Anyone remember what is different about a parallel circuit? Go to someone else. What is different, Chanel? Okay, I see you. Go ahead.
A parallel circuit has more than one path to lead to.
More than one pathway. So with that reminder on your screens, go ahead and answer 15 and 16. Make sure you do 16 A, B, C, and D.
Carlo, you need to turn a light on. We need to see your face. Some people even have their pens on paper that we can see, which is awesome. But expectations, at least have your light on, just like that. Perfect. Keep it like that.
Tanzel needs to mute. You gotta mute yourself. Where's Tanzel? I'm gonna scroll down from 15 because I think that I think we should have be able to have completed 15 by now. So anyone that still needs to look along can see the final circuit here. Let's take another. Show me on your hands if you need one more minute for this. So give me the number 1 if you need one more minute. If you're ready now, then just put your hand down. If you need at least one more minute, show me the number 1. Okay, so we're gonna take another minute. Jessica, I see a hand up for you, so I'm coming around to you. Yeah, Jessica,
I think Vicky also has a question.
and then Vicky. Yep.
I can't see the question for number 16.
Okay. It asks you to just identify if it's parallel or series.
Okay.
Okay. Vicky.
And that's what I was gonna ask, but also I have another question.
Yeah.
Is there gonna be any text there? 'Cause I want to read one.
Is there going to be any text
Yeah.
to read? Well, not in this lesson today, because this is basically a review of the previous unit. Tomorrow we're going to start a new unit, so we'll definitely have texts to read. Okay. Let's go over number 15 right now. So 15, a light bulb in a circuit will work if the circuit is. All right, let's put up our fists. 1 is A, 2 is B, 3 is C, and 4 is D. When I count down, show me your answers. So answers in 3, in 2, in 1, and show. Yep, it should be 4D, closed. You need that pathway. Volunteer for, actually, I'm gonna go ahead and I'm gonna fill these in so you can check your answers compared to mine, and then just raise your hand, unmute yourself and ask me a question if you're not sure why. Number A, this is gonna be parallel. This is parallel because there's more than one pathway. The electrons can either flow around in this small loop to get from the battery around back to itself, or they could go around the bigger loop and then back to the battery. So there's 2 pathways.
Tanzel, please don't do that.
Jalen, for B, do you think that that's parallel or series?
Boy.
Parallel. How many different pathways are there in that circuit?
4.
Yeah, there's 4 pathways. Each of these loops, there's one there, then there's one here, and then there's one that goes a little bit bigger, and then finally the biggest loop that goes around the whole thing. There's 4 different paths. What about C? What do we think about C?
Tanzel, once again, put your leg down.
Leilani, what do you think about C? Somebody's whispering on their microphone, so we need to make sure you're all muted.
For C,
Yes.
I said it's parallel.
Do we all agree? Anyone disagree? Kaylin, what do you think?
I said it was a series.
So why do you think that it's series?
Because like there's only like I don't know, because there's only like one pathway for it like to go.
All right, so let's go ahead and take a look. I'm going to start here at the battery, okay? I'm going to start at the battery. The electrons could go around, and they could go through resistor 1, and they could go through resistor 3, and then come back down.
I thought we were doing the next one, sorry.
Oh, okay. Or the electrons could pass through the smaller loop and then still come back to the battery. So this is not series. This is actually a parallel circuit. And it's kind of like a combination, series and parallel circuit, because you could think of it as if resistor 1 is in series with the parallel combination. of resistor 2 and 3. But it's not just simply a series circuit. There's more than one pathway, so you could call it parallel. Kaylin, you thought that we were working on D?
Yeah.
Okay, so Kayla is saying that D would be series. Do you find an answer?
Bailey
Kaylin, do you
selected.
stick by your answer?
Thank you.
I said that I think it was D because this one I only see one pathway for it to go.
Yeah, there's only one pathway. All right. Any questions? Any questions on Ohm's law, on finding voltage, power, energy, or the difference between parallel and series circuits? I'm scrolling through, I'm looking for hands. Okay. Carlo, you gotta fix your camera. Bailey, I'm not sure if you're awake. Please come back to video. Okay. All right. Magnets. This is probably a little bit fresher in our minds because we did magnets more recently. We've got, let's go through these 18, 19, 20, and 21. Let's go through 17. I think we should be able to do 17, 18, 19, and 20 in like 2 minutes. I think we should be able to do that in about 2 minutes. So take 2 minutes and then we'll share out our answers. So do 17, 18, 19, and 20 right now.
Time to watch your video. Vicky, let's get on task. Are you on task? Thumbs up. Everything good, Vicky?
Once you've finished, just give me a thumbs up. We still have about a minute left. Okay, we're coming back together to review the answers in 20 seconds. Okay. So 17, the north pole of a magnet. What is it? What does a north pole do to a south pole? North pole and south pole attract. 18, the north pole of a magnet does what to the north? There should be a blank line here. Does what to the north pole? Well, they're the same poles, so they're gonna push against each other. They're going to repel each other. South pole and south pole, they're also the same pole. Point your fingers in if they're gonna attract or out if they're gonna repel. They're going to repel each other. Magnetic force is blank at the poles of a magnet. Our answers are more positive, more negative, strongest, and weakest. I'm gonna go ahead and I'm gonna tell you it's not A and it's not B. Can someone explain why it's not positive or negative? What is this confusing magnetism with? Tanzel's got his hands up. Go ahead, Tanzel.
Yes. So that's confusing magnetism with electricity. Because
That's right.
electricity is the ones with the positive and negative. Like the poles, there's the north and the south pole, but there's no positive and negative poles. So
Right. So think back to our when we actually had that experiment where we put all the iron filings near the magnets. Where did all those iron filings where did they all line up? They all mostly lined up near the ends of the magnets, near the poles. So it's strongest. The magnetic force is strongest at the poles. We did these, we've drawn these diagrams a bunch recently. So I'm actually going to, yeah. We also just did electromagnetism. Let's review. Draw the field lines for A. So right now we're all drawing the magnetic field diagrams for A. 21A. Yes, go ahead, Jessica. All right. You may have already done, let's see. I probably should erase this circle there. So the magnetic field lines go from the North Pole to the South Pole. If you already did B, you may have done it. I didn't tell you to, but you may have drawn the magnetic field lines like this. And if you did C, the magnetic field lines would go like that. And these ones could actually extend all the way to the back. Rules about drawing magnetic field lines. We need someone to mute. They never cross. They never cross each other. And always go from north to south pole. They always go from the north to the south pole. All right, so we're gonna wrap up this part of the review session. Most of the rest of the review is stuff that we've done most recently with magnetism and electromagnetism. But what I will offer, because we have lost 40 minutes off of this review session over the past 2 days. If anyone would like to meet for like 15 minutes at the end of the day, I can give you a code for my room, like I do like an office hours. So if anyone has any questions or wants to go over any of this review material, maybe like at 4:45, I can do that. It's optional. If you want to do that, just chat to me right now. Even if I get just one person, I'll come in and I'll meet with you.
Sandra, what's your question?
I don't have a question.
Okay.
Oh, be
So,
careful when you raise your hand because.
all right. So at this moment, I have no requests for an office hours today reviewing any material. That's because I asked you to chat it. So I'm looking in the chat and I don't see anyone in the chat that's asking for it. All right. Okay, that's great. I'll be there, Tanzel. Anyone else? I'll give you my personal ID and we'll meet later.